Hello and welcome to The Enterprising Investor, the flagship investment podcast for CFA Institute. I'm Mike Wallberg, and today's guest is Brian Pisaneschi, CFA. Brian is a senior investment data scientist at CFA Institute, who was, impressively, recently named one of Investment Week's asset management game changers of the next 30 years. With a background in quantitative finance and a research focus at the intersection of data science and sustainability, Brian is helping shape the future of investment automation. Today, we're going to talk about a research series Brian's been working on that dives a little deeper into how AI tools do what they do and what opportunities that may create for investing. His work aims to demystify AI and empower investors to experiment with low-risk, high-impact applications, and I, for one, look forward to our little tumble down the rabbit hole. Welcome to the show, Brian.
Thank you very much, Mike. It's good to be here.
So let's start with the basics in this piece that you put out for CFA Institute, Brian. You talk about retrieval augmented generation. What is that, and how does it fit into the big black box that we know as AI in quotations?
Yeah, so I think a lot of us are probably used to going on ChatGPT, uploading documents whenever we want to try and bring in some external information. And essentially, what that is a retrieval augmented generation system. And so it is a way that we've essentially, us in the machine learning community, have been able to provide more updated information or also more real-time information when we can connect it to, say, the internet. We can pull in more information because these large language models have cutoff dates. So they have training dates. At that point, they no longer have any information, so they hallucinate things that they don't have. So we've used retrieval augmented generation to essentially, you get a question and it is connected to this what's called a vector database. And essentially, it's going to go into this vector database and find chunks of text that are most similar to the question. So, if you were, asking the retrieval augmented generation system that has uploaded with proxy statements, which is the example in the case study, about, executive compensation of the CEO, it's going to pull in, say, the top 10 chunks of text into the context window of the large language model. So that's what the large language model can see. So once it has that, then it can ground its answer off of that information. So it's essentially just a way for us to reduce those hallucinations, have more updated real-time information. And yeah, it's been kind of the go-to tool for that use case right now.
So you've said that RAG, or retrieval augmented generation, works well then for the qualitative data, and that's what you looked at in here, but struggles sometimes with quantitative analysis.
Yeah.
Can you walk us through why is that, and is there anything that investors should be thinking about or keeping in mind when they're using these tools?
Well, first off, the large language models aren't meant to essentially, perform calculations. That's never what they were intended. They are these autoregressive generating of words. So they're just taking previous words and they're coming up with the highest probability, which would be the next token, which is a word in our example here. And they're just generating. So, like, for example, like math, if you asked it, a highly complex mathematical question, it actually might get pretty close. It'll actually get to a certain, probably a decimal point to the right answer. But then it just starts hallucinating because it's seen those questions and it has a probability of what the answer is, but it's just hallucinating it. So it's not meant to do those quantitative tasks. Now, in terms of when we are interfacing with these documents in a RAG setting for the example in the case study, which is interfacing proxy statements, a lot of where the quantitative information fails, it stems from its ability to extract it from tables. So you have a lot of that quantitative information in tables, and a lot of the times the tables are just, in different structured formats, and it just is lacking in its ability to pull out the right information versus, say, in a passage of text, it has, the context of the words leading up to, answers. It's pulling that in to its context window, and it's being able to answer that question. So it has a lot to do with the structure of the text and how the structures differ between different reports as well. But one of the things that I mentioned in the piece is that really a lot of, the quantitative information, the qualitative versus quantitative information, if you're just doing single queries, just interfacing, what was CEO's X's, executive compensation um, for this period, it does a pretty good job just single query interfacing. It starts to get complex and it starts to lose its accuracy when you start asking it, highly complex and nuanced questions, including, say, in a case study, extract executive compensation for, company X, company Y, company Z, and then it has to pull in from multiple sources and it starts to lose some of its accuracy there. So it really stems from, okay, it is fairly good at single query interfacing, but it starts to lose some of its accuracy when you start to, add really, complex, nuance questions. And this is where agents come in. This is where agentic workflows come in, where you actually can split up a complex task and really leverage that single query, accuracy.
So would this be the hybrid automation, this idea of kind of having multiple tools that are doing the things that they're good at? So large language models are good at language, at figuring out that, summarizing, generalizing. And then we have calculators, right? Like,
Exactly.
why don't we don't really need these AI tools if they're not good at it. Plug a calculator in. Can you talk about that? Like, what does that look like?
Yeah, absolutely. I mean, that's literally what everything, VC companies, if you look at, say, Y Combinator right now, is like 73% of VC right now is all trying to build these agentic workflows. So the agentic workflows essentially do exactly that. These large language models aren't meant to do math problems. So then you connect the large language models to accurate data that you can pull in, similar to retrieval augmented generation, but it has access to functions to pull in correct data, to pull in correct, financial metrics, so that it doesn't have to try and do these calculations and make mistakes. So that's where agentic workflows come in handy, where if you have a highly complex workflow, you can break that up into steps. And then at each step, you can, go out and have the large language model connected to APIs, so application programming interfaces that are connected to accurate data. You can have it connected to a calculator, to a Python interpreter, so it can run some data analysis, which is, these large language models have quite, grown in their accuracy for coding abilities. Coding and software engineering is a big cost center for firms. So that has been the main kind of objective is to get these large language models really good at coding so that they can, you know, hopefully reduce some of the costs that go into.
I was just trying to think, is that irony? Is that like punishing the creator of the monster, basically? You do
I
all this
mean,
work to make something so good that it puts you out of the job for these poor developers.
I think that there's a lot of irony in that. I think that the LLMs are still just not they're not good enough to completely get rid of software developers, that's for sure. And I would strongly recommend people who are interested in finance and also interested in the tech side to still, learn about the tech, learn what's under the hood because, well, for one, competitive advantage is found really on the edge of that existing technology. So if I tried to create an agentic workflow right now just using a large language model, so there's a term in ML space called vibe coding. So that's just where we work with a GPT or Anthropic Claude, and we just ask it a question, code up some process, and we copy it, we throw it into our Python interpreter, and then we see if it works. If it doesn't work, then we ask Claude, ask GPT. We just vibe. So if you just tried to vibe code some of these new ways to create agentic workflows, you're going to run into a lot of problems because, as I said before, these large language models have cutoffs. They have to pull in the correct information. They don't always go out to the internet and pull in the correct documentation to be able to do these more novel, coding tasks. So you still, you will very quickly run into frustration. But that's just one aspect. The other aspect is the fact that these workflows that are being used to automate these processes are still very much rooted in the computer science kind of way of structuring an entire workflow and being able to think like a computer scientist, being able to, really outline how a workflow could be automated is going to help you even in a no code fashion. So this is when we start talking about, these platforms like N8N or Zapier. These are designed for people who don't want to code, and they're these kind of graph structures that allow us to create these agents, where we connect them to outside, data platforms. So if we want to create, some valuation model or scenario analysis model or something like that, we have one node and we connect it to the input data we are in, and then we, just like you would do in GPT, we give it a prompt, analyze this data or clean this data, and then it moves on to the next step, and then it brings in other data or some other step in the process. And this is all done without code. But the entirety of building this structure is very much rooted in being able to think about how to automate this entire process. So it's a way of thinking that I think is still very much important going forward.
So you're describing taking sort of the data science approach and applying it across kind of how we do our day-to-day jobs. Talk about the inverse of that. Talk about human creativity and curiosity. What do you see as their role in all of this?
Well, for one, I think that that's the biggest thing that we as an industry need to be, sending out the alarm bells, because I think in our industry, we've downplayed the need for creativity because a lot of our workflow didn't involve highly creative tasks. But if we really want to differentiate our ability from AI's ability, I think that is it. In 10 years' time, I still think human creativity and curiosity are going to differentiate us from AI's capabilities. So the industry needs to be giving their teams a lot of space to be able to exercise that part of our brain. Because if you don't give the teams the ability to exercise that part of your brain, it's the same kind of discussion that, we talk about even with software engineers. It's like, okay, well, right now GPT is an intern, is like a 24/7 coding intern that you would give to a software engineer, which leaves the junior software engineers lacking the ability to get any experience.
Mm-hmm.
And so if you don't have something set up in place that is going to give them that space to still really, exercise that ability, I think that we're really, shooting ourselves in the foot. So I think that absolutely curiosity and creativity fundamental going forward. I think that the industry is kind of on a path to being a lot more scientific, a lot more creative in that aspect. You need to be able to know what these tools are and the technology that exists. But most of the competitive advantage is going to come from your domain expertise and really having that holistic idea of the entire, finance industry, so that you can find those little pockets of value that, are hidden and also not the norm because, as we can see, like within GPT, they're biased. Like there's a lot of things that are built into the training data that just kind of guides an LLM to the majority because it's seen it so many times, and that's what kind of allows it to become biased. So, it really is important for us to understand where those biases are, how we can mitigate them, and that's
That's so interesting because it means, I mean, in this industry, and I've worked as an analyst before, and it's part science and part art, always, right? It's as a fundamental analyst, anyways, and to a certain extent, quants as well. But if you're just what you're describing is where this, you're going to really need to lean into the art more to on the one hand, lean into the art more to find your edge, to find those opportunities. But I find that really interesting, this idea that if everybody starts relying on the same large language models and they're all, it's like anything in investing, right? If you start to drink the Kool-Aid and you believe what market consensus is, but now the market consensus is going to be coming from the biases in these models to the extent that people are relying on those models for the science part of their job.
Yeah, and I mean, but to go back to, the retrieval augmented generation, essentially that really allows the analysts and the PMs to, inject their own creativity into the models. So the large language models they're based off of the attention mechanism. So they've been trained to really, place attention on certain words in a passage of text in order to accurately output, the next word or next token. And so if it has all this bias information, but then you give it updated information in your retrieval augmented generation system, or you've given it a prompt that is very guided towards your secret sauce, it's going to attend to your secret sauce. So it does still give the analyst the ability to be creative and add their own competitive their own alpha that they've found and over the years of developing it. So, you know, as much as it will, kind of go and I would say default to the what it's seen in its training data the most, you still have that ability with, some prompt engineering, as you mentioned before, it's that art. I've personally believe that prompt engineering is a lot more of an art than it is a science. There's a lot of, basic structures of prompt engineering. You give it a role, you give it a task, you kind of give it some limitations or guardrails of what it should and shouldn't do. You give it examples and you give it a format, but those things are just kinda like basic things. Most of what I think to be really good prompt engineering stems from your domain expertise or your ability to communicate. Like, it's the same kind of like really good communicators are gonna produce much better prompts and they're gonna get better answers because if you can add that nuance to really get down to what the task is, you're gonna be a better prompt engineer. So, I really think that, again, is just like what you're saying. It's just more of this kind of art part that we can inject into these large language models.
What's a big misconception that investors have about AI right now?
Hmm. Well, I mean, personally, I think that there's been a misconception on they'll look at GPT, they'll have some answer that it doesn't actually, produce it correctly or it failed at whatever task it gave it, and then they just kind of brush it off and they say it's no good. I think that level of perception and the capabilities of these models is lacking the nuance of the fact that when we really can connect different external data sources and when we can define a process, a workflow with guardrails, with evaluations that we can do, that the capabilities of these things are far greater. And so I think there's a misconception of just kind of brushing off his capabilities just from the use of say ChatGPT, the platform that's on ChatGPT. And I think that if you have a team that can help you build these workflows, I think that there's a lot of capabilities. And I think kind of rooting on that, I think that what a lot of when people talk about agentic AI or AI agents, they look at these kind of autonomous systems that are going to be, super difficult to audit, super difficult to keep track of, and really think that, okay, this is just not something we can work with. But going back to the workflows, I think that absolutely, you know, giving an agent so much autonomy is most likely going to be a disaster. But again, if you can break down a workflow into individual steps, and at each individual step, you've established what is an accurate kind of output from that, and you've run evaluations, I think you can do some really great, robust things.
So breaking it down into steps it sounds like it's a way to kind of create your own audit trail, avoid the hallucinations, be sure that it's not just like making something up at the last.
Yeah. Yeah, I think that that's where we're headed for, a good amount of time. I think that the really autonomous agents are quite a ways away in a highly, a lot on the line in our industry, a high risk of output, which is really what, you need to think about when you're thinking about automation. You have to think about, okay, well, is the risk of this task something the output of it, can we handle that? If it is, then, maybe that's a task for automation.
Hmm.
But I think a really good way to kind of think about, automation tasks is to think about where you had naive approaches for doing things in the past, or where, being able to scale up, or just like manual process that you couldn't do to a high degree in the past can now add more nuance. So if you had a stock screener that you had some kind of like binary filters on that stock screener to create, I don't know, some sort of custom index for a client, that those thresholds that you just put in place, you can add more nuance now with large language models that can pull in different context for those thresholds. That I think is basically like looking at a problem and saying, okay, this is a nuanced task, and I've kind of, because I'm limited of time and effort, we've created this kind of process that is, naive in its attempt. Well, now we can add more kind of complexity and robustness into our stock screeners with large language models and things like that. So
So Brian, we're coming to the end of our chat here today. Unfortunately, I'm going to hit you with our two-part final question here. What was your first job in the industry? And if you could go back and take yourself for coffee on your first day, what key piece of advice would you offer yourself?
so first job was an accountant, corporate accountant with a property casualty insurance company. What would I say to myself? Well, I would say that be as true to yourself as possible, and take as much risk as you can, and everything will work out. I think that that's it.
I've been speaking today with Brian Pisaneschi, CFA, Senior Investment Data Scientist at CFA Institute and author of RAG for Finance, Automating Document Analysis with LLMs for the CFA Institute Research and Policy Center. You can find it there on the CFA Institute website. Thanks so much for coming on the show today.
Thank you, Mike. It's a pleasure.
I'm Mike Wallberg, and this has been The Enterprising Investor.